So here I have some operations. Let's say for argument's sake, this is a auto merge op. We've end-to-end encrypted it, and we have another device, and we send it over there. And because it's end-to-end encrypted, in this case, we don't have to worry about here and there at all anymore. It is the auth has traveled around, in this case, with the encryption. So when we started working on this stuff at Fission, we really, 5-6 years ago, had this idea in our head on the left, which is how most apps are set up. You have data at the bottom, you have something like Postgres. Above that, you have some compute layer, Node, Rails, whatever it is. And above that, you have an auth plugin. But because we need this auth as data picture, auth actually lives at the bottom. It has to secure the data no matter where it lives. And it has to support the data layer and make sure that any writes that you do get packaged up in the right way, that they're secure, and that anybody who is reading that data and able to decrypt it is able to validate this is a real authentic use, or not from an authorized user. So it actually lives at the bottom, and you have to solve it first. I think the way things tend to get built, where you build out the data layer first and you kind of like have it with you and your friends, and then you add data later, or you add auth later, makes sense. Because for you and your friends, it's not like you're trying to do something in production. But it does, then you have to go back when you want real production use and add this auth layer at the bottom. So because this is group managed, so unlike something like UCAN, we know the members in the group, and we can give them different levels of access. So at the bottom is pull or copy. This is the ability to grab encrypted bytes from another peer, typically a sync server, but not decrypt them. Then you have decryption. So you've somehow been shared the key. We don't have time in this 15-20 minute slot to talk about BChem, but for those that follow that world, we've taken TreeChem from MLS and made it concurrent, causally consistent. You need to be able to do writes. So if you can write things, you need to be able to decrypt them. If you can decrypt them, you need to be able to pull them. So there's this hierarchy here. And then finally, admins who can kick people out of the group. So we have this strict hierarchy. So instead of this picture that I gave a few slides ago, the way that we authenticate changes is every document is identified by a public key, and it can delegate to someone else with a signed token. Hey, I, the document, give Bob access to make changes to me. So this would be an auto merge document identified by a public key, says, yeah, Bob can do this. And then after it's done that setup, Bob is now the owner, it deletes his private key. So there's now no one else can take and issue this root certificate. It's just Bob is now the owner. Bob wants to invite Alice and writes another token that says, I, Bob, sign something with my private key to Alice, and that's all approvable with public key crypto. And Alice then wants to write into the documents. And to do this, she includes references to the previous two tokens. And we can then form this graph of authority that says, this document delegate to Bob, delegate to Alice, and has closed this loop again back to the document. So we can self-authenticate regardless of where it lives at any point in time. This is a valid write into the doc. Further, because documents and whatever you could build out of a document, it could be a directory, all of these things, an auto merge document, all have public keys. And we don't make a distinction between users and documents. Documents can say, hey, if you have access to me, you also have access to them. So you can now build up things like file systems, databases, things like that. If you have access to this directory, you have access to all of its children, that kind of thing. Instead of having to manage hundreds of thousands of keys, because CRDTs tend to build up quite a few changes, we chunk together changes. So AutoMerge has this compressed format that uses run-length encryption, things like this, and cuts down, I think it's 100 times or 1,000 times, compression. It's very good compression. So, but keys don't compress. So we take runs of changes, encrypt them with, compress them, and encrypt them with a single key. And then we can hand that key out to somebody else. They can grab the data, decompress it, unencrypt that one chunk. But now there's later changes that have also been compressed. Well, I only want to have to share the one key. So we include the keys to all previous, or at least to the direct ancestors in the next chunk. So if you have access to the head of the document, you can discover its parents and its parents all the way back to the root. So I have to share you one key, you can get the entire document at that point in time. And as soon as you have this key, you now have the ability to delegate that key to somebody else. You can just make a copy of it, give it to somebody else, and now they can also read the document. For connections between documents, these graphs of documents I was mentioning before, we have three concepts. We have individual users. These are actually down to each browsing context or device. Groups, which are collections of keys that can be added and removed, right? We have that admin concept. And documents, which are groups plus some associated data. Which means now we can have these graphs of authority, and I can play it forward to say, who has access to this document? Well, that has been delegated to a couple of groups, and from the groups to a couple of users. So I know it has just the leaves of this graph. So it has these two for Bob, the farmer guy at the top, and one for mechanic on the left. Going the other way, if I say, well, what can this astronaut see? We can just play the arrows backwards and see it's these documents that these arrows touch. So this is really helpful for something like a sync server to say, somebody shows up and says, hey, give me all the documents. I don't even know which ones I've been added to yet. It can take that user, play all those links backwards and say, here's your set of documents that you're allowed to see. You'll notice I haven't talked at all about identity or key recovery. We've abstracted those out. So as long as you can do public key cryptography and encryption, this works with any of those systems. In fact, we're working with some other folks. Emily is a researcher, for example, working on key recovery right now with Martin Klutman over at Cambridge. User identity, there's about 1 million user identity systems. You could use pet names, you could use something that hooks into OAuth, all of these different systems. This supports, Beehive supports any of those. You just have to be able to provide a public key and be able to sign things. And that's, slightly over time. Almost made it under the wire.
That's wonderful. Wonderful talk, Brooke. And also not that over the wire. We took a few minutes trying to do community announcements. If you stop sharing, I'll
Okay.
be able to intro Nico and hand it over to him. All right, next up we have Nico. Oh, wait, where did I have my slide? There we go. Uh, He's, I think, a one-man army. Do you have a team with you? Because I looked through your docs and all the work that you're doing, and it is insane. You're taking on a lot, and it looks really interesting to build graph local first experiences. If you think about it, that's kind of what reactive data stores should sort of allow us to do, is build really complicated graphs that are like two-way bound so that each node can kind of like update and propagate across. And it's really exciting I'm really excited to hear what you've been up to.
Thank you, Jonathan, for this nice introduction. Very nice introduction. It's true, I'm alone. I have a few contributors, but for now, it's one show. Yes. Um, Everybody can see my screen. Am I live?
Yep,
Yes.
you're coming in great.
Okay, great. So I'll switch to the presentation slides by doing this. Click here. You can still see me in the
Yep,
there,
bottom
but
right.
you see mostly the slides. So I'm Nico. I'm the developer of NextGraph, and which is an end-to-end encrypted local-first platform based on graph. It's a graph database on the semantic web. So I'll explain most an introduction about the semantic web, what it is, what are graph databases, and then we'll go over the other subjects, but very shortly. I have 15 minutes. Um, so what is this semantic web? Semantic web linked data or giant global graph, it's an idea that was spread by Tim Berners-Lee, and it's quite old. 25 years ago, we started to hear about it. Um, he invented the web. We all know that. So we had the web of pages like that, HTML, Ahref with HTTP protocol. And then we wanted the web of data instead of web of pages. So what is it? It's more something like that. If you know UML and you represent objects and their classes and their relationship between them, you have this, which is here we have two objects of the class person. And the first object describes Alice, and she was born in 99. And then we have Bob, who was born in 2007. And we also say that Alice knows Bob, but we don't say if Bob knows Alice. It's a directed relationship. We can see that, and this is UML. It's also old. But that does not give us a framework or a platform, right? It's just a language to describe graphically some data and their model. So then the W3C standardized RDF in 2004, which is a format for data. And it's used in academia industry. Wikipedia extracts its data, all the data in its articles, into RDF, and it's called Wikidata. You can query it. It's a simple format based on triples. What is a triple? So a triple establishes one fact about a resource, and then a resource is composed of several facts. One triple is in fact composed of three parts. You have the subject, the predicate, and the object, and it goes in that order. So we'll see what it means. A subject is like Alice. That is, I will establish facts about Alice. I will say that she lives in Wonderland. Wonderland here, it's a value which is a literal. It's a string. But then I can also create a resource for Wonderland. What is this Wonderland? So it can become a resource, and then I will say it's created by Lewis Carroll. This time, it's a string again, Lewis Carroll. I could add more properties. I could say when it was that it's a book, when it was first published, and things like that. So now that I've created a resource for Wonderland, I can say that Alice lives in Wonderland, but Wonderland is not a string anymore. It's a link, a reference to the resource that we call Wonderland. That's a big important difference. So in the object, we can have literals, like integers, booleans, strings, but we can also have references to other objects or resources. So let's dig a bit more. Inside the predicates, which is in the middle, the created by lives, they are always represented with a URI, which is for now mostly a URL. By example, http test.com, no, by example, xmlns com fof 01 knows. This is an ontology. We have an ontology here at this file, at this URL, which will describe all the types of predicates I can use. Fof is an ontology which means friend of a friend. I will use it later. And then we have the subject to the left, Wonderland or Alice here. These are also represented with a URI. by example, so http test.com/alice. Now, the relationships are directed, as I said before. So here we have Alice. Its birth year is 99, but 99 is not Alice is not the birth of 99, right? Alice knows Bob, but we don't know if Bob knows Alice. If we want to say that Bob knows Alice, it's like this. It's Bob knows Alice. Now, these triples are stored in a database that we call a triple store. There are several implementations in Java, one in Rust that I'm using because NextGraph is coded in Rust. Then you have the query language for this database is called Sparkle, and it's similar to SQL. You can filter with where clauses or and more. The good thing about Sparkle and RDF is that you have automatic joins. You don't need to declare foreign keys in your schema in order to join tables. You can join all the data on all the predicates by default. Another advantage is that the schema is embedded in the data. So you don't need to carry a schema on the side of your data or to make migrations, as we saw, because the schema is the predicates, right? And they are inside the data. So this is a query, a Sparkle query, a very simple one. I'm going to ask now, I want to find all the person. This is my variable here. Find me all the persons that knows Alice and also that were born in 2007. There is only one person like that in our triple store for now, and it's Bob. That will be the answer. So what do we have? A web of data 2.0, the current one, which is with triples and resources stored on different domains, test.com, example.com, mydomain.com, and they have resources like Alice, Bob, and Wonderland. Now I can establish facts between them, and this is cross databases, right? Here I have the fact about Alice knows Bob, Bob knows Alice, and Alice lives in Wonderland. This is a web of data, but it's not decentralized. Why? Because it's still relying on DNS and HTTP, which is not really decentralized. And then you need to buy maybe a TLS certificate or whatever. And then it's not portable because every time you change, you move your data from one server to another, the domain name changes, and then the unique identifiers of the resources change. And that's not portable. So 25 years later, we're still looking for this decentralized web of data. NextGraph brings decentralization, CRDT, and end-to-end encryption into the mix. We believe it's important to stick to RDF and also to JSON because JSON is much more known than RDF, and it's here to stay. As I said, we don't use HTTP. Instead, we replace everything with DIDs. DID is decentralized identifiers, also a standard from W3C. And it's getting some traction recently. So the URIs that I was talking about before for subjects and predicates and sometimes for objects are DIDs. They are unique, they are permanent identifiers because they are never going to change. We generate randomly a public key for each resource, and that's how we have this DID. The DID is quite long. We also use it for self-sovereign identities because our user get IDs, which are DIDs also. They are long. Like here you have an example. We replace test.com/Alice with did, ng, and a long string like that that can even be even longer than that. But that doesn't matter. It's not human readable, but these URIs never were meant to be human readable. That's not where the human readable thing should be. It should be in the predicates. Like if you want to give a name to your resource, you use the predicate RDFS label, Alice, for example. So now, as I said, we have also local first, and because it's CRDT based. I implemented a new CRDT. We have CRDTs, libraries like AutoMerge or YGS, but I implemented one for RDF because there was nothing existing. Based on a scientific paper, a formal research. Updating the graph is done with Sparkle updates. Each replica locally has a Sparkle endpoint. Insert data. here I insert in my, I don't need to say in which resource because I know it already. So this is a placeholder. And then I put the property or the predicate name, Wonderland, and the description, a fictional country. Now I want to update that. And in Sparkle, it's done like that. In RDF, it's like first I remove the triple that was saying the description is a fictional country. And then I insert the new triple, which says description, a fictional place. And this is a transaction, and we will call it a commit in NextGraph. I can put many operations like that in one transaction. So because it's CRDT based and local first, I will not talk about that, what it is, because we are on the 20th episode of this podcast, and I think you all know what it means to be CRDT based and local first. But it means that basically you can have concurrent updates and that they will never conflict. We're using the observe the remove set mechanism for resolving these conflicts. And when a concurrent delete and insert happen, the insert wins. It also, this CRDT also gives us access to the history of modifications, and we can query with Sparkle the database, the state of the database as it was as at a given revision ID, a commit, by giving it the commit ID. It can be handy to go back in time. Eventually, the NextGraph protocol, the sync protocol, is CRDT agnostic. It means that it can transport all kinds of CRDTs. So there is first this RDF CRDT, but there is also YGS and AutoMerge that we use extensively in NextGraph. And we could add more CRDTs in the future. There is LoRo that is now getting also some attention. They just released their first version, stable version 1. And diamond type's a bit older. I think it's only about text, but we could still integrate more CRDTs if needed. That's for the thing. So each document is composed of the graph part, which is the triples, and you can add to it a discrete, what I call a discrete part, like a sidecar, which is optional, which can be used to store JSON. And here you have the choice of using or YGS or AutoMerge. So all of that is queryable with Sparkle and eventually with GraphQL, because we can emulate GraphQL on top of Sparkle. You can also attach binary files to documents as much as you want. So this is an example of a document in NextGraph which is going to store some rich text. It has a URI, and then some binary files that are attached that also get a URI, a unique URI, which is content address, by the way. And then you have the graph part of the document, which is here giving it a name, what is the default image that we should use, the summary, and when it was created. And then we have this discrete part of the document. Here we're going to use YGS to write some markdown, because this is going to be a rich text document, as I said. And here we have the markdown example, and it's CRDT based, obviously. The same could be done with some JSON here, and we could use AutoMerge or YGS. They both do some JSON-like data structures. And here I've put some binary file, which is the CSV source of the data. Why not? It's just an example. Here it's another example in the context of a social network. We have the profile of Alice and the profile of Bob. They both have a did, and then they have some graph data. We found again this triple that says that Alice knows Bob and that Bob knows Alice. We also have a photo for the profile and the label, and we have a discrete part in the document, which is a YGS markdown, which is the bio, the description that they write about themselves. Hi, I'm Bob, the classical body of Alice. I dislike Eve, who is nosy. And hi, I'm Alice, a well-known computer geek. Schema and primary class. So as we saw before, we have these predicates that are gathered into ontology files that describe what you can do, what are the data types, which we call classes, And you can reuse these ontologies between documents, between applications, between servers, between replicas. You can share them. And to reuse ontologies brings interoperability, because then we have a shared schema between users and applications. There exist already several ontologies that are popular and that address the basic use cases, and they are all exist for 20 years. They are waiting for you to use them. And there are also the industries also writing ontologies for specific industry domains of data. Then each document must have in NextGraph a primary class, which will be used to link this document, to map this document to, and to know what applications can be used to open this document. Like you have in your operating system, you have these files and you know which application can open it. So here it's exactly the same concept. And an application is a viewer, a set of viewers and editors. When you are a developer of application, you're going to create viewers and editors on the data. There can be several, and you will set to which data types, to which primary class which ones you will be able to open. And then users install your apps and they can use them to manipulate their data. We will give a set of official apps that will open the common document types that we have. And users, of course, can switch and use others. It's an open and malleable system that connects apps to data. These apps can run inside our apps. We have apps in NextGraph. I will talk about it after. And they can also be standalone apps that run like an Android app or an app that you install in your desktop, or a web app that is running on a server that's totally standalone and doesn't have anything to do with NextGraph. But you still need to connect to NextGraph somehow in app in order to get the authorization for the data, the access grants. Because NextGraph is managing a wallet that I won't talk about it today, with the permissions inside. The framework for apps is not ready yet, but the APIs are ready. But what is missing is this access grant mechanism, that an app will ask for the permissions to use your data. And you will say yes or you will say no. And you can revoke these permissions also at any time. And this framework will be ready in 2 months. It will give APIs for Svelte, React, and Vue.js in the front end, which will be based on reactive stores. So you directly have access to your data in JavaScript, in TypeScript, and it is reactive. If there are some updates that happen concurrently, you will get them without doing anything. As a programmer, you don't need to worry. The data updates will come to you. And if you change the data locally, it will be sent in the protocol, it will be encrypted, all will be done transparently for you. The same will be available in Dino and Node.js and in Rust. Example of applications that we would like to give already to the end users are here. There are the classical apps that everybody needs daily. And then more apps could be created, like a Notion copycat, Gmail, Instagram copycat, personal knowledge management system, productivity suites, and services that have access to the data. We believe that copycatting the very good UX of the big tech products is a good idea because users are used to them, and also they are very good. They invested a lot of money in that, and we can just reuse that. We can copy their UX. So NextGraph is private by default. I'm going to be very short on the permissions and capability topic because Brooke already explained it very well. In NextGraph, it's similar. It has differences with what Brooke is doing with AutoMerge and Beehive. But I'll skim. I'll be very generic. Today I don't have a lot of time. So it's private by default. In NextGraph, everything is encrypted end to end. You have 3 stores when you create a wallet by default: the public, protected, and private. It's private is you cannot share it with anyone. It's only for you to sync between your devices, but that's all. Protected is where you create documents that you share with others. And public is everybody can read it and even edit if you give the permission without checking permissions. So you can create more stores if you want, like groups and organizations. And the store is where you put your documents, right? It's like a bag of documents. All data is encrypted at rest. That's very important, with convergent encryption for the commits in the DAG and also for the binary files. And but this commits of CRDT, they are materialized locally, which we call the materialized state. I'm sure you heard about that before. It's the data, the document that can be used locally. So this is encrypted also. We keep it locally with symmetric encryption. And then we have the transit, the protocol. It's based on WebSocket, and we use the noise protocol inside the WebSocket. So we don't depend on TLS and certificates, which is not a decentralized architecture. Permissions are granular at the document level, not at the triple level. And
Nico, just sorry to interrupt,
yes,
just a time check as you're going along.
yes, I don't have more time, right? 5 minutes, maybe even less.
Yeah.
So I'll skim very quickly. We have inheritance of permission at the store level, and also it's transitive permissions. You can include the permission inside the document, include the capability, and then it gives access to this document, to other documents and other people then. So then about the architecture of the network, it's almost peer-to-peer. Why almost? Because if you are only peer-to-peer, you need another replica to be online at the same time in order to synchronize, which is not guaranteed to happen. So we have a network architecture which is called two-tier, and it's based on brokers that sit in between replicas, like the sync server that Brooke mentioned before. We would like these brokers to be self-hosted. We, for now, give public brokers to be used, but we will encourage people to self-host those brokers. And they don't depend on TLS. We just use bare IP. Convergent encryption, I will skip. It's about how we encrypt end-to-end inside in the DAG of commits and the binary files. So this is also the DAG of commits. It's not going to be here. It's a nice presentation on how the DAG starts on the left with the root commit that Alice created the document. And then we add commits one after the other in the DAG. Alice added 3 commits, but Bob also added a commit concurrently to Alice here at the level of the 3rd and the 4th. Here we can see that the commits have 2 parts. They have a header which is not encrypted and the data inside which is encrypted, end-to-end encrypted. And this is the same mechanism, I think, than what Beehive is doing. It is that we have a reference to the causal past. Here, the number 3 reference number 2, number 2 reference number 1. Number 4 of Bob, also reference number 2. That's how we know that they are concurrent, because there is a fork here in the DAG. And these references are split in 2. It's the commit ID and the key. The key goes to the encrypted part, and the commit ID is in plain text. It's not encrypted, and this is for the brokers to be able to see them and to be able to deal with the DAG and to help with the synchronization protocol. Now, the difference with Beehive is that here, the last commit ID and the commit key, which is the head, here for now we have only 1, but if we were at the previous stage, we would have 2 heads. This red part here above my head is going to be sent into the pub sub of NextGraph, which is a publish subscribe mechanism that's the broker are maintaining. So you just need to subscribe to a document and you get all the updates, which are basically this encrypted red block. It's encrypted so that the brokers cannot see it neither. They don't see this this symmetric key here. So We have a mechanism of branches in NextGraph, which lets you uh, create more blocks, basically, of data inside one document. You have you can create many blocks like Notion is doing, and that lets you also do partial syncing, which means that inside one document you can have several blocks. They can have different CRDTs. They can be based on different CRDTs. They can have different data types, primary class, and you can decide to sync only partially your doc according to the blocks that you're going to use. I'm not going to dig more into the rest, the sync protocol. I will share this PDF to everyone in the chat, and you can read it later or ask questions in the forum if you are interested. The right capability neither, I won't detail how the events are propagated into the PubSub neither. How to share capabilities I will skip. And the pool control, which was mentioned by Brooke before, which is very important, especially here because we have conversion encryption, which is which can be attacked with a confirmation of a file.
Mind wrapping up, Nico? We're going really
Oh,
past beyond.
sorry. So we use outer and inner overlays to control at the network level the pool access. We have external signatures, which are based on threshold signatures for which is a bit borrowed to the blockchain world. And you can verify the signatures with the document ID and a chain of certificates. This I will skip, and also that. The framework will be ready in 2 months, as I said, and the current status that you have the app you can try. We have native apps in Linux, macOS, Windows, and Android, and soon iOS. And it's an open platform, an open sync protocol, an open ecosystem. We are welcoming everyone to talk with us if they want to integrate end-to-end encryption and CRDTs in their application. And we are in talks with several other projects for collaboration, and we just published the Activity Pod collaboration, which will bring solid and Activity Pub compatibility. Those are the goals. The final goal is to regain total control over data and software ownership, and to be able to compete with big tech with malleable software and a unified UX if we can. If you let me do the demo, it's 2 minutes long. Otherwise, I
Maybe
will skip it.
let's do that after the Q&A
Okay.
session. We're 30 minutes in now.
Sorry. Thank you very much for your time.
Yep. Thank you, Nico. That was I know graphs, we have a lot to cover. And between you and Brooke, this is going to be a recording that I'll keep referring to quite a few times. And now I'm going to kick it over to myself. It's a little weird introducing yourself. But yeah, I've been on this local first journey sometime since around, I want to say 2017. I would end up moving 5 times in 2 years, and it was not a pleasant experience trying to like go around, find all my addresses, and try and update it everywhere. And that's when things started to really bother me, and that's kind of how I got started with this local first journey. So this talk is mainly about why we need local first and the details around like what are the available opportunities. Also kick back and enjoy the show for a bit. First, the average person right now lives like this, and it is insane. That is the world we accept. And if you try to integrate anything, you're looking at an O of n squared integrations. And this is not the world that we deserve. It is not a fact. It is not some limitation of technology. It is truly essentially just the choice of platforms siloing and maximizing their profits instead of profit being the engine for progress. In short, this sucks. We need to change it. And local first provides the only possible path to it, in my opinion, with the user being the common denominator that allows us to integrate these disparate, disconnected items. Maybe let me do something real quick. Yeah, this might be better. So if we have a world where our data warehouses are kind of seeded by all of the disparate apps, we can live a world where the user has a connected, composable, extensible, malleable experience instead of this fragmented nonsense that we're dealing with today. And that is really my passion. And I'm taking an AI approach, but at the end, I'll have a call to arms for everybody because I want to be able to build this app where I have to-do lists, notes, and my calendar kind of working together without me manually having a to-do checkbox, a timeline view, and then like manually also doing the calendar. And guess what? This costs $19 a month if I wanted to get it from a couple of applications. Email is also another one. You want to have a Kanban board for people who you've talked to, and then you want it to update automatically when somebody responds. All of these things are very disparate silo solutions that don't ever work because you'll reach for that one piece that you desperately want, and then that silo doesn't support it and it doesn't play well with others. So you're just left being mad. So let's get back to why local first. I fundamentally believe the user as the common denominator connecting all of these disparate silos is the path forward. However, there's the saying, the reasonable man adapts himself to the world. The unreasonable man persists in trying to adapt the world to himself. I hope there's a few of you out there chuckling already because the rest of the quote is, therefore, all progress depends on the unreasonable man. And this really spoke to me because I have been unreasonable a lot of times. But also, there's this tension because I do like money. So we should all strive to change the world, but profit is a great engine of progress. So we can leverage profit, good business models. And here are some really insane market opportunities that work for us. So if you have connected information, the friction just goes to zero. Like wallet-based logins, if any of you have tried MetaMask, is just like phenomenal. You click a button, you hit accept, and all of a sudden you're in a new platform, authenticated and signed up with just an accept button on your MetaMask wallet. If you had connected information, imagine your streaming history from Hulu, Netflix, kind of streaming into the next new platform you try, and the AI working better to give you a consolidated interest profile of everything you like to enjoy watching, not your Prime suggestions, not your Netflix suggestions, and your Hulu suggestions. But at a grand scale, pre-trained models have now democratized internet inference or machine learning. So we went from the past where you had this like baby that couldn't really see and like could connect shapes of blobs of people to cluster them together and recognize objects, which I'll call collaborative filtering. So the more blobs of people and large number of users this machine learning model could see, the more it's able to kind of discern different shapes. The pre-trained models now have like high definition, like quality eyesight. They can now actually see. So the race is not for gathering the most number of users so you can kind of infer what interests are there. The race is now for high quality first party data where like what's your name, what's your resume, what's your interests, what are your profiles, so we can even do content based relevance, assistance. And if you think about it, all of the incumbents today have an innovator dilemma. Is Google really going to risk a $300 billion search ads business to then do ads personalized by your personal data by connecting with other platforms? Or if you think about Facebook being like composable from different accounts like Blue Sky, Twitter, you're risking a lot of existing business. So we have not only a business case of like just 10 to 50x better user experience, but we also have a lot of strategic kind of alignment that allows us to disrupt all of these sleeping giants. And that's why I like to say, change the world and make a lot of money. It doesn't have to be one or the other. Now, to what I promised about local AI, Vella, which I'll get into in a little bit, is built with all local AI. We don't have a backend, we don't have a database. We're doing everything in your device. And this was brutal. Like, I can't stress how annoying it has been. For people starting off, you have three primary options. There's this executor for LLM inference, Onyx runtime, which is a lot more durable, a lot more widely used, and MLC the AI, which I'll kind of call the blazing fast inference model. The challenge with trying to do LLMs in your mobile is like first you'll be limited to very small sized models. We're talking 1 to 3 billion, and quantization can kind of get you to access maybe an 8 billion parameter. There's this wonderful paper by Brave that describes like you can run 600 LLM prompts before you drain the battery on a phone. So all of these constraints exist, but I'm going to stay the irrational man. And in our case, we kind of did a bunch of BERT models. One, we have a binary classifier. Then we have a logistic classifier to build the email organizer app that I'll tell you in a little bit. But at a high level, if you have to do something that you want to run fast, I would have to pick MLC. If you had to do something that you think will improve and you'll have to do over multiple years, Onyx runtime is widely adopted, so I suspect they are the more enterprise bet. Executorch is setting up a lot of partnerships with chip providers like Qualcomm, and they're PyTorch backed, but it doesn't seem like they're resourced as heavily as any of the other two. I'm excited about these. I guess I got these confused. So this MLC was supposed to be like fast and durable. And durable and hardware acceleration it doesn't belong here. So what does that look like in practice? You'll start loading the model. It could be anything between 500 megabytes to like 4 gigabytes. There's a lot of memory challenges you might run into. You'll start the session, but then when you're about to load the model, in if you're doing mobile, like is there really a path? What's the file system? You'll have to figure that out. Float 32 array is not a JavaScript. We were using React Native. It's not a Swift or a Kotlin kind of type. So you kind of have this type marshaling because these run with C underneath and they have bindings for C. So where you're left at is all of these hodgepodge kind of annoying problems because you're off the beaten path. Again, the irrational man. So we got Vella, but I'll tell you in just the next slide. I know I've been promising you what I've been building, but let me tell you a little bit about my journey. I had that same insight that we need to connect data across all these fragmented silos. And I have enough development experience to know Greenfield is nice, but you really need to tackle the brownfield problems. So password manager was our first approach to be able to like create an edifice around that complexity so that you can have a password manager that can log in and update your personal like information like address, credit cards. And the key idea was you just hash the nonce and maybe your password is Superman. So there's no vault. It would be like just a transformation on a memorable thing that you remember and a complicated thing that's synchronized and provisioned on your devices. Then I was like, okay, people don't really get excited about password managers. And it was like an RSS feed uh, plus all your socials. That's what you're seeing right here. Vibrant content aggregators, kind of what we were pitching. And the whole goal, again, is to build a personal data warehouse. And this whole journey has been very challenging. And part of it was that I just didn't find my people. Like I like hanged out in the solid spaces. Fission was very fission focused, not really vibe focused. Met some DWeb people, still planning to go to the DWeb camp. And Web3 was just like like shit tokens being marketed everywhere. It was kind of a tough environment to kind of try and like find more people building this. So I'm really happy that I found my home with Local First and ever grateful for Ink and Switch for that paper. Came around 2019, but I caught on to it in 2021 and ended up kind of really helping champion the movement because I truly believe that we can get there. Now, what is Vela? It's an AI powered smart inbox. And the goal is like you don't need 16 emails or 12 emails happening one at a time. You need the right information surfaced at the right time. So if it's like right before your flight, you want directions and maybe you want to copy the confirmation number. You want it organized and you want to swipe it off. And Amazon sends you like 5 emails with every purchase. You wish you could just lump that in and like get the latest update and if you need to take action or swipe it off again. So this is kind of what I'm talking about. Like if you had a personal graph that kind of worked to organize all your information, you can do a lot of powerful things like what I just described. And we are launched on Product Hunt with our MVP. Please don't expect a lot. Again, MVP, MVP. This just helps you quickly organize your email into different buckets, create rules in your mobile. Like it's surprising, but Gmail mobile app doesn't allow you to create Gmail filters. You have to like open the web portal and then do that and quickly try to unsubscribe and archive. We're trying to validate that you can use all local AI, zero servers, zero databases to be able to do valuable things. So then people can have their own personal data warehouse that works for them instead of for different apps. And the future is bright. Like these are insane total addressable market opportunities, and the user has the most data on themselves. So, what do I want to leave you with? Local first needs you. We need to connect, whether it's peering agreements or whatever the case, the data infrastructure available, being able to talk amongst each other and create a personal data warehouse for everyone that can react from both my to-do list notes and my calendar, or if I need to do an email funnel, being able to like respond to a Jira ticket that is updated automatically by my email. I shouldn't need to try and solve these things in individual silos like Google Workspace or Notions or Apple's or anything like that. Could have a truly composable, pick and choose, Legos, not silos world. And that's what really gets me up and fired up every morning. And that's what I hope that you all will get to really get excited about. So stay irrational to change the world, but also make sure you use profit as your engine. And thank you so much for all the love in this community. I this is a labor of love for me, but it just nourishes me so much that I cannot describe how grateful I am and how lucky I feel to be part of this movement with you. And we hope, and I hope that we'll all drive it. That's all I have for today. We'll do a quick round of questions and then like maybe like one or two burning questions, and then I'll circle back to Nico's demo. Thank you all.